For this problem, we want to find the surface area that is created when we rotate this little piece of arc around the y-axis. So the curve itself is y equals 1 plus the square root of 1 minus x squared, which is, of course, a half circle, semicircle that's been shifted up 1. But we only want to look between the points 1, 1 and the square root of 3 over 2, 3/2, which 1, 1 is right here, actually. And then the square root of 3 over 2, 3/2 is right here. Now, because we're going around the y-axis, that means that we know that we're going to do this with respect to y. So we know that it'll be dy as our integrand, or our differential for our integral. So, well, if I'm going to go with respect to y, then I care about the y values. So this is going to be c, and this is going to be d. So down here, it's c equals 1. Up here, it's c equals 3/2. Now, I know it seems a little weird because you're going from right to left, but that's irrelevant because we're looking at the y values, and so it doesn't really matter. All right, now let's think about the formula for the surface area. So if I write down that formula, it's going to involve, let me go down here, surface area equals 2 pi, the integral from c to d, which I could put those in right now, g of y, because there's my radius, 2 pi r, that's how I rotate it, and then the arc length, 1 plus g prime of y squared dy. All right, well, to make this work, I already know c and d, so that's beautiful, right? It's 2 pi integral from 1 to 3/2, no trouble. But what is a trouble is that I don't actually have a function in y. I wasn't given a function in y, I was given a function in x. So I need to solve this for x. So just for starters, as I bring this over, I'm going to subtract 1 from both sides. So let me kind of bring that over here. So it'll be y minus 1 equals the square root of 1 minus x squared. All right, that means y minus 1 quantity squared is equal to 1 minus x squared, which means x squared is equal to 1 minus y minus 1 squared. Bring the x squared over, bring the y minus 1 squared over. So x is technically plus or minus the square root of 1 minus y minus 1 squared. Now it's plus or minus, but of course we can't use that. That's not a function, right? We can't have one y value assigned to two x values. That doesn't work. So we actually have to choose the positive one. So because we're in quadrant 1, because we're in Q1, choose the plus sign. And that means that our function g of y is equal to the positive square root of 1 minus y minus 1 squared. Okay, so that's going to go right there for that piece. But now I need to find the derivative of it. So if that's the case, remember this is all to the 1/2 power, right? So the derivative would be, bring the half down, so 1/2, 1 minus y minus 1 squared to the negative 1/2, times the derivative of the inside. Well, the derivative of 1 is 0, so that's not a problem. And then we'll have negative 2 times y minus 1. Technically times 1, but it's irrelevant because the derivative of the y part, right, y minus 1 part is 1, so it doesn't matter. All right, rewriting that, that's negative 2 times y minus 1 in the numerator over 2, and then a square root, and a 1 minus y minus 1 squared. Just to clean that up just a touch, I would divide away those 2's. So it'll be negative y minus 1 over the square root of 1 minus y minus 1 squared. Now, I know what you're thinking. Well, you could distribute the negative. Sure, but you kind of don't need to worry about it because you are going to substitute it in. And if you notice, it was going to be squared. So you don't need to worry. All right, so let's substitute. So for g of y, I'm going to put in this big square root, 1 minus y minus 1 squared. And then a big square root, 1 plus, and then it's negative y minus 1 over the square root of 1 minus y minus 1 squared. And all of that is squared. dy. All right, well, when I square a square root, when I square all of this, the negative is going to turn positive, and then the square root in the denominator is going to disappear. So this will be 2 pi integral from 1 to 3 halves, square root 1 minus y minus 1 squared. All right, now I'm going to leave myself some space here. I'm going for something with this. So 1, leave yourself some space. Trust me on that one. Big gap, plus, and then let's see what happens here. So it'll be y minus 1 squared over, because the negative will disappear, and it'll just be y minus 1 squared. And then 1 minus y minus 1 squared dy. Now, why did I leave myself that big space? Well, I want to combine like terms, right? Because this is kind of yucky otherwise. So I want to make this 1 turn into something that I combine. So I'm going to give it a common denominator. So instead of 1, I'm going to write 1 minus y minus 1 squared over 1 minus y minus 1 squared. Then they have the same denominator, and I can combine like terms. Yay! So this is 2 pi integral from 1 to 3 halves, square root 1 minus y minus 1 squared. And then now underneath here, it's 1 minus y minus 1 squared. Let me write it out. It's 1 minus y minus 1 squared plus y minus 1 squared. All divided by that common denominator of 1 minus y minus 1 squared dy. Now, why did I do that? Well, because minus y minus 1 squared plus y minus 1 squared adds to 0. And then I'm left with the square root of 1 on top, and the square root of 1 is 1. So, one more time. This is 2 pi integral from 1 to 3 halves. It's pretty rare that we can actually do this particular surface area formula all on our own. Most surface area formulas are actually so difficult you can't do them. But this one we can, because that's 1 in the numerator, because the square root of 1 is 1, over the square root of 1 minus y minus 1 squared. And hopefully you're thinking what I'm thinking. That's a numerator, square root 1 minus y minus 1 squared, and a denominator. And they divide. And all you're left with is 1, because the square root of 1 is 1. Lovely. So this is super rare. This does not happen very often. But we are going to take 2 pi integral from 1 to 3 halves of 1 with respect to y. Well, the integral of 1 with respect to y is y. So we're going to take that from 1 to 3 halves, which means we're taking 2 pi times 3 halves minus 1. 3 halves minus 1 is a half. Which means pi inches squared is our surface area. All right, let's double check ourselves. Let's go back here. All right, so when we look here at the integral calculations, so we have that little piece over there, the orange part. And so when I click on the integral calculations, you can see that I name my function g of y right here. And then I just tell it 2 pi, and I type in the formula, and I tell it I want to go from 1 to 3 halves, and sure enough, it's pi.